This video will explain the convergent or divergent integral test. So when you solve an integral, is the solution to that integral convergent or divergent? So convergent means that the limit exists and is a finite number. And divergent means the limit does not exist or the limit is positive or negative infinity. So this is a test from the solutions of integrals for convergent or divergent. To better explain this, we're going to walk through this example. So we have the integral of 1 to infinity of 1 over 4x plus 2 quantity cubed dx. So to solve this, we're going to first step back and say, okay, we need to solve this integral to know if it's convergent or divergent. How are we going to solve this? What's the easiest steps? For this integral, we're going to use the u substitution method. In the u substitution method, you pick a part of the integral that has an easy derivative to simplify the solution. So for this integral, the most complicated part that has a derivative is 4x plus 2. So everything that's in that parentheses that's getting cubed. So we're going to pull that out and call that u. So that becomes u equals 4x plus 2. We're going to take the derivative of 4x plus 2, which gives us 4, because 4x, the derivative of 4x, we can split it into 4x and then 2. Find the derivative of each term. So 4x, the derivative of 4x is 4, and 2 will just go away. So u equals 4x plus 2, the derivative, so that du, derivative of u, so we did this left-hand side, and we have to do the right-hand side, equals 4 dx. The next step that I like to do is solve for dx, because that's what we'll be using to plug back into the equation. So dx equals du over 4. So now that we have a dx and a u, we plug those values back into this integral equation. So instead of having 4x plus 2 in parentheses cubed, we're going to just say all that is just u cubed. And now we have this dx term we have to sub in, which now dx becomes du over 4. To simplify this, I pulled the 4 out, so it's 1/4 integral of 1 over u cubed du. So now we have to solve this u integral. To do this, we're going to use the power rule. The power rule is when you have an integral, it equals u n plus 1 over n plus 1. So in this case, our n is negative 3 because it's on the bottom. So anything that has any value when it's on the bottom becomes a negative root. So you can either write it 1 over u cubed or 1 over u cubed or u to the negative third. So to solve this, we're going to say u equals n, which is negative 3. So u equals negative 3 plus 1 over n plus 1, which is negative 3 plus 1. So u equals negative 2 over negative 2, which equals negative 1/2 u squared. So now we're going to solve so that the negative 1/2 u squared is the solution to the integral of 1/3, as shown here. But we got to remember that that 1/4 carries down, and since it's outside the parentheses, we could solve this 1 over u cubed and not have to worry about the 1/4, but it's still there as part of the solution. So we have that 1/4 negative 1/2 u squared, because the 1 over u cubed, that's the solution to that. So we can simplify this out to equal 1/8 u squared. But since we still have u and the original equation was given in terms of x, we have to plug u back in and get everything in terms of x. So we have to undo this u substitution. So we had u equals 4x plus 2. So we're going to plug that back into u. So we have negative 1/8 4x plus 2 squared. And we're going to solve that for infinity and 1, because that's what the original integral was being solved for up here. So we're going to solve this for infinity and 1. So we plug infinity in first and then 1 and we subtract everything. So we have negative 1/8 times 4 times infinity plus 2 squared minus this entire quantity with a 1 plugged in for x. Because that's what this infinity and 1 is being plugged into. So we have negative 1/8 times 4 times 1 plus 2 squared. So let's simplify these. So this left-hand side becomes negative 1 over infinity, which goes to 0, plus 1 over 8 times 4 plus 1 plus 2 squared. So that becomes negative, not negative. The negatives cancel out because you have a negative negative. So it becomes 1/8 6 squared. So that equals 1 over 8 times 36, which equals 1 over 288. So since that is a finite number, that means this integral is convergent because it went to a finite number. So above here, the solution to this integral is convergent. It is not divergent. If this answer was negative infinity or positive infinity or did not exist, it would be divergent. But since it came to a value, it is convergent.